Today I will demonstrate to you how to migrate from Oracle Tuxedo to Enduro middleware. This demonstration is based on sample application which uses features typically employed by enterprise applications, such as x8me servers, x8me clients, FML buffers, /queue persistent queues, automatic queues, data-dependent routing, and global transactions. In this example, x8me client generates transactions as FML32 buffers, and these buffers are sent to entry service, which in turn enqueues the request data to persistent queue. As this queue is automatic, the messages are forwarded to one of the two groups of TXlog services, where each of them uses different database schemas for data storage. The particular tlog service instance is selected by DDR rule. Let's go through the sources. Sample application uses FML32 buffer format. Here are the fields defined. Enduro provides all the same build tools as Tuxedo, and in this case FML32 header generation tool will work as expected on both platforms. Next, let's look on the transaction generation client. The transaction generation client program is standalone binary which performs transaction buffer preparation and calls the entry service via standard TP-call function. Let's see the makefile. As we can see here, the client is built by the build client tool. Let's look to the entry server. Here entry server initially opens XA subsystem, advertises entry service. Entry service receives a call from the client and then it enqueues the data to TXlog queue. This process is done in scope of the global transaction as entry service is configured with auto-tran setting in UBB configuration file. Next we will check the TXlog SV process. Data in database is submitted by ProC x8me server process. The server receives transaction data from TXlog automatic queue. The service reads fields from the request buffer and performs insert into database. Let's see the makefile. Build server tool is used for x8me server building, and build TMS is used for transaction manager preparation for Oracle database. Now we will check the configuration files used to describe the application. We have environment settings here, which are applied from the UBB configuration. The UBB configuration file is quite typical. This demo is based on single machine module, but Enduro also supports the clustered UBB configuration file migration. So we have group section here, we have server section here, we have persistent queue elements defined, we have entry server defined here, we have transaction logging to database servers defined here. Different sets of the servers are living in different groups. We have service settings for automatic transactions and a routing mark for TXlog service. And finally, here are the data-dependent routing rules used for TXlog instance selection. So about the migration process by itself. We provide extensive developer guide describing the migration tasks. Here is a document. When performing the migration, software must be rebuilt for the Enduro middleware. As our APIs are compatible with Tuxedo counterpart, this shall not cause any issues. Just run make on your application with Enduro configured in the environment. However, configuration file formats are different for Enduro. We provide tool named UBB2X, which converts the Tuxedo UBB configuration file automatically to Enduro format. The full process how UBB2X converts the configuration file formats are described in this document, and users may perform manual conversion if necessary. We recommend to study this guide as it would help to quickly get familiar with the Enduro platform. This guide also explains how common administration tasks are done in Enduro. Now, let's try out the sample application. Firstly, we will install the Endurex middleware on the server. We have already downloaded the RPM package, just install it. Once the package is installed, operating system settings must be adjusted according to Endurex administration guide. For Linux operating system, limits shall be increased. That is already done on this particular server. Settings for the queues shall be applied. As with the limits on this particular server, that's already done. We can cross-check that with setting lookup. Now let's try to build and run the sample application. Firstly, we will clone this repository to the disk. We will change the ownership to the user 1 as Tux app uses such configuration. Let's log in as user 1 and change the directory to cloned project. We can see the environment files here, and for the Endurex x.env shall be loaded before the build or runtime start. Let's see the settings used. Those are not many, as RPM package is installed system-wide. Next we will load the environment. Once that's done, we can build the project. Project has been built successfully, so we can proceed with the configuration. Let's convert the UBB configuration to Endurex format by using our automatic conversion tool UBB to X. We can see that 3 new files were generated: the environment loader, XML process description configuration file, and any configuration file used by each process. This defines additional environment settings which shall be loaded before runtime is started. The XML configuration file describes servers, services, clients, and routing. Please check the migration guide for more information on similarities and differences between UBB configuration and Endurex XML configuration file. Let's see what's inside any file. The global section describes settings which are similar to Tuxedo resources section. Then we have these subsection settings which are called CC tags and Endurex, and they function in a similar way as groups for Tuxedo. CC tags can be linked to different binaries in the XML configuration file. In these subsections, XA and DDR routing settings can be applied. This section describes debug settings for binaries. The settings Endurex and UBF are log levels for Endurex internal logging topics. The setting TP configures log level for user application topic in case if Endurex logger is used by the application. This section describes persistent queue settings. Endurex doesn't require any scripts or any special initialization of the resources to use the persistent queues. Endurex uses file system directories as a spool for the persistent queue data storage. Here particularly txlog automatic queue is defined. Note that migration tool only performs basic setting migration, as UBB to X parses only information from UBB configuration file. It does not analyze Tuxedo queue creation scripts. Thus, in more complex migration scenarios, this section needs to be reviewed. Additionally, we can see that some directories were created, like tmlogs. This is the directory used by transaction managers to store their machine-readable log files for the in-flight XA transactions. For persistent queues, directories were also created, and here the queue space data is stored. Empty folders are prepared, which during the runtime are used as a dynamic storage. Now let's proceed with the application startup. Firstly, we will load the environment settings, and then we can do the startup. Before we run transaction generator, let's check that database schemas are empty. Now we are ready to run the transaction generator. This generates 100 transactions and they are submitted to the queue. Let's check some statistics. As we can see that 50 messages went to one TXlog SV binary instance and other 50 messages went to other copy of the binary. Messages were distributed by DDR rules. We can check some queue statistics. We can see that messages are processed. Now let's check the database records. So we get 50 records here. And another 50 records here. So it's success. To conclude, this small example shows how easy it is to migrate from Oracle Tuxedo to Enduro middleware. Thank you very much.